Just a comment, Dave. There's a lot of material there, a lot of food for thought. So I think most of us will go in and try and digest it, but there's a lot there.
Yeah, yeah. Look over it if you have time. And I truly believed, for me, it was kind of revolutionary in my life about 5 years ago when I had somebody ask me, "Are you free?" And my answer quietly was, "Well, what exactly do you mean by freedom?" Um, so, dear God, thank you for this
That was
time
good.
together. Go ahead, Matt.
Oh, no, I was just going to say, it's a good word, Dave. Thanks for putting that together.
Thank you for this time together. Help us to be thoughtful, considerate of others. Help us to feel freedom, and help us to make a desire for freedom and contentment. And help us to understand what you mean by freedom and who we are. Amen. All right. Scour and pipeline protection. So back in 2015, I was asked by a close friend of mine, Lee Forbes, to go up to North Dakota and help him out with a scour assessment on the Yellowstone River in late October, early November. Late October, early November can be a pretty scary time in northern North Dakota. It can get kind of cold, and we wanted to do a river assessment. But the nature of this project was they were putting in a proposed pipeline, and they wanted to figure out, they had some pipeline exposures where pipelines had broken and have contaminated the Yellowstone River. So they wanted to make sure that this line was going to be deep enough, and every foot deeper that you go on a pipeline crossing costs you more money. So we're trying to figure out how deep this had to go. So the first thing when we looked at the banks of the Yellowstone River was that this was a wide channel. There was mid-channel bars that were formed, and they weren't vegetated. It gave us, you had a lower bench, bankful bench that was formed on a bank that was vegetated, but yet these bars were formed in the middle of the river. And it was a big river. 1,060 foot wide is what we saw on the day when we were out there, with mid-channel bars forming from just a few 15 years earlier to 20 years earlier. This was a 1,750 foot wide channel. That was its bankful channel for most of the documentation by looking at things. We had small gravel bars. We had depositional bankful benches, islands that had built up. We had mid-channel bars. We had abandoned high terraces and a sedimentary rock cliff. So Lee and I had to figure out how to get some data on this. We couldn't get anybody to rent us a boat because everybody had put away their boats for the season because it's November in North Dakota. Nobody wants to be on the water in November in North Dakota. So we bought a little dinghy from Bass Pro Shop, blew it up, and tried to go down the Yellowstone River with a 6 foot wide aluminum paddle. As you can imagine from the smirk on Lee Forbes' face here, he did not have a lot of confidence in our means and methods. But we went down, we collected some data, we classified this river as an over-wide C5 high width to depth ratio sand bed system at a super low slope. So it was a C5, C negative. Our cross-section showed a sedimentary rock cliff and then a series of terraced alluvial valleys off to the side. We looked at an uncertainty of bankful, and we had an uncertainty of bankful for a cross-sectional area about 10,000 square feet to about 14,000 square feet. We had about a 16% uncertainty in where we called bankful. Bankful was not at the top of the bank. This was still operating in some ways as an F channel transitioning to a C channel. Our idea was we wanted to put down a pipeline. We wanted to just make sure that we had enough scour depth so that in the next 100 years plus for the lifespan of this pipeline, that the river wouldn't be cutting down into this pipeline. So the first thing that I looked at in looking at this, we looked at a cross section, we looked at a profile, and the pools, there were pools, but they weren't super deep pools out here. and it seemed to still be an over-wide system. We had a very fine-grained sediment. Our D50 through a series of sieves was under 1 millimeter, so it's a finer sand. You can see the ripples in this photo that were forming near a mid-channel bar and stuff, so you can see the movement of wash load even at low flow. But there was a lot of colonization of vegetation, cottonwoods, and willows on here. High sediment sources from these mid-channel bars forming and pushing out the banks, and then just fine-grained sandy materials falling into the river and forming more bars. So we knew that there was a transition here that would occur. We went upstream to gauge, and we wanted to figure out how much flow the bank full had, and then also what the 100-year discharge was. And, you know, was there things that we could look at here? What we identified as bank full downstream, is this comparable to gauge record? What's our recurrence interval of that? So we just did a standard gauge analysis on here. And we looked at it and said, okay, we had about 50,000 CFS with a 10% uncertainty of our bank full discharge. We had 103 years of record. Our maximum discharge for 103 years of record, so it would be essentially your 103-year storm event, would be about 142,000 CFS. So plugging this in, this is going to be important from a scour analysis. Scour analysis is always going to be related to your period of record. So most scour analysis look at a 100-year recurrence interval for their scour analysis. So we are essentially transitioning from an F channel to a C channel. And as we looked at aerial photography from 1949, this channel was 2,300 foot wide. By 94, it was 1,750 foot wide, and now it's 1,060 foot wide, but it's still a very high width to depth ratio. And it's still the stream that's transitioning to a much smaller channel. So when plugging in the values to standard scour equations, so we looked at Lacey 1931 and Blench 1970, a lot of these factors related to discharge and channel width are very important for how scour is assessed because it's related to your depth and your slope of your flow. So then that will produce how much scour you could potentially have in the channel. So for us, we thought it was important to figure out, okay, what happens within a 100-year period? We expect this channel to become a lot narrower and a lot deeper depth. So what happens at that point for our scour analysis? So even though today we're looking at something that's 1,060 foot wide, well, in 1949, if I did a scour analysis for 100 years, I looked at something that was 2,300 foot. So my depth's gonna be a lot shallower, which means my scour protection could be a lot less, or I won't have to put this pipe near as deep. So what we did was proposed a morphological adjustment and said, what happens, where could our reference width to depth ratio be, and how deep would this be long-term for us to give a scour assessment to this long-term? And what we did is we looked at the scour assessment and we said, okay, what happens if this channel continues to narrow up and we're going to move somewhere closer to 700 feet or 750 feet opposed to this 1,060 feet? So what could this channel look like at that width? And then what would the pool depth be from standard references? So then what would our pool depth be, and then what would be our scour related to that lateral scour for pools, as well as the bed scour for the riffles. So what we looked at from a profile was our maximum scour depth from the riffles and the pools, and then we ended up just taking the maximum and doing a depth off of the pools. And then we looked at that compared to the proposed pipeline location. So what we saw is that we were still 20 feet below the proposed pipeline location. And we could have told the pipeline people, well, bring up your pipe some, but our idea was, well, we don't really care to tell them to bring up the pipe any, but we're showing that you have a lot of protection from this pipeline is protected from the potential morphological adjustments of this channel. Now, if you think of the position we're in, we're not too far south of the mouth of the Yellowstone River as it confluences with the Missouri River. So you'd have to have a base level shift that would be significant on the Missouri River for us to have a base level shift from this maximum scour depth. The entire process of how we put this together, I shared with you today with the PowerPoint presentation as a draft version that we put together. I didn't have the final version on me because Lee Forbes did the wordsmithing and put it together. But you can follow that, and I'll give you some ideas of base level shift. But what I wanted to really point out today is this idea of, if we're looking at pipeline assessment, we have to be looking at future morphological shifts as well as just the current in-time condition. Because for the most part, pipeline assessments are looking at periods of design that are 100+ years. So for us to look at, okay, this is just what the river channel is now, without us looking at, okay, what happens, what could we predict could happen in 100 years, and then looking at the scour analysis would be kind of insane. We'd be looking at something and saying, okay, well, it doesn't matter how much deeper this channel gets and how much more scour we get in 100 years because it's stable today. We have every likelihood of that happening later. So let's look at the trajectory of channels when performing scour calculations. And trajectory can be slow or rapid, but we also need to know our design lifespan. So that was kind of my summaries today. I just wanted to share what we had done years ago in looking at this morphological shift for scour analysis, which typically isn't done in the industry. So,
Dave, I have a question. So let's say the pipeline came back to you and said, we need to move that pipe up. Like, is there a certain minimum freeboard that you're comfortable with where, you know, from that maximum scour line that you had projected?
Yeah, well, the scour lines, and if you look at the report, you'll see all the different equations that you can go to. What we did was the maximum scour of all the equations involved. So from my standpoint, if they fought it, I'd say, well, there's already a factor of safety built into the scour analysis, so you could come up to that scour level there. But the political idea of, with the regulators, of how much deeper, sometimes they'd say, hey, we want to be 2 foot of freeboard or 4 foot of freeboard. But I'll leave it open to anybody else on the line, but I've never added a factor of safety onto scour analysis beyond what the scour analysis itself has for factor of safety. Yeah.
Understood.
Yeah, and the industry generally has it varies a little bit from company to company, but they generally got an industry standard of minimum amount of cover that they want over their pipes. So that would enter into the equation as much as anything.
Yeah, that's correct, Brad. Yeah.
Hey, Dave, you're going to go back in 100 years and see if you're right?
Oh, you know, I don't know if I'll still be around at that time, but
I'll meet you there.
The pipeline things are always interesting because, you know, it's so neat to go back and look at them in 20 years and see kind of how the morphology adjusts. Last night I was looking at some trajectories of rivers on the Illinois River that I did almost 7 years ago now, and just kind of watching how things adjust, especially on the big scale river, on these bigger rivers. A lot of times, you know, your adjustments are more noticeable in aerial photography. So.
Well, I find it really depressing working with these pipeline companies on occasion, because we had one where we recommended that they lower it and that they put it in lower than what they were planning on. And you know, I said, well, it'll save you money in the long run. And they said, well, the installation is a different department than maintenance, so we install it as cheaply as we can. And if they have to spend money after the fact, that's a different budget, so we don't worry about it.
What a mess.
That's pretty horrible.
Yeah, that. I was like, you got to be kidding me. And they went, no, that's what drives our bus. And so since that's, you know, they have to worry about it in 20 years, not us, so we don't care.
Yeah. Yeah, I don't know if anybody else on the line has done. I used to work for a company, and we got into a lot of pipeline assessment stuff. And it seemed a lot of times the pipeline assessments seem to be pretty magical where the numbers come from. And because there's just so much data that people have to put into these models that sometimes, you know, you put in this data, but you get to a point where you realize that you don't even really know the data that you put into the equation. So my emphasis on this was really just, we're going to have such a high degree of uncertainty when it comes to scour calculations as it is. But most people believe that most of these scour calculations over predict scour. So at least that's good. That at least we want to make sure that we can predict how the channel adjusts. And if we expect it to be a lot deeper channel in the future, let's make sure we model for a narrow width to depth ratio in the future. All right. Well, any other comments this morning?
Not for me, Dave. We'll talk to you about Alabama sometime today, okay? Are you around?
Yeah, I'll be around today. If anybody has something they want to share kind of from a technical standpoint or even from an inspiration standpoint, I know George Kelly is going to have a guy that's going to be speaking on an inspiration talk that he's an author and stuff. So he's going to be hopefully talking with us in the next couple of weeks. But if you have something you want to share, by all means, let me know. And we're happy to let people share either in the technical or the inspirational side. I know not everybody on this call comes from the same faith journey as I do. And if we're focused on things being good and true, it does not have to be from the same faith journey that I'm in. So we recognize that people are in different parts of their journey, and we want to see that from both sides. Technical stuff. This talk was from 2015, so it is not new to me, but it's new to most people on this line, on the call today. And don't think that we need to have, if you want to share something technically, it doesn't need to be something that's brand new to you, but if it's something that people can learn from as a group, and if you look at it and say, hey, there's probably over half the group that doesn't know about this or hasn't heard or hasn't thought about this or even thought that it was a problem, those are good things to share. So it's going to be more fun as more people present. That way you don't have to listen to me quite as much. But we look forward to it. Keep me posted if you're interested. I think that's about it for this week. I'll stay on the line if anybody has any other questions or ideas related to scheduling. And I really appreciate everybody being able to make it today.
Thanks, Dave.
Have a great week, guys.
Thanks, Dave.
Thanks, Dave.
Hi, Dave.
Hey, Bassett, how you doing?
Good. I'm looking for things to do this week. A little bit of, I think Ralph Hall still is there, but I'm not sure about anything else.
So the other thing I want you to do is this morning, let's say after the SWC, are you usually on the SWCA calls in the morning?
Yes.
Okay. So after the SWCA calls, because that pretty much takes up a lot of our morning, after those SWCA calls, let's get together with you and Joseph. And we need to finalize the cut fill balances for all of the oxbow ponds minus the big one at the end of Willow Branch. So we've kind of done that a couple times, but we're back into the point where I want to make sure everything gets balanced and that we have good quantities for the guys at Res. We're going to provide that to them, the finalized design, by next Friday. No, by this Friday. So we're going to have you work on kind of the oxbows. So between now and after the SWCA phone calls this morning, just get back familiar with the most recent design for the plugs. I'll send you the PDF, and then you can follow the link on the side of the PDF to see where the drawing was at and see where the most recent drawing is. So this will be kind of the same stuff you were doing back in February in Sri Lanka. It's just finishing up the task because we've moved back and forth a bunch. So.
Okay, so we'll talk with Joseph after the calls?
Yeah, we'll talk with Joseph after the call. Before then, before that time, if you run out of stuff to do on Ralph Hall, then you can start looking at where the most recent drawing is for the plugs. But what I want to do is have all of the I want to have all the plugs designed into the surface and make sure that we have a quantity for all of them. They're going to have Hammets guys do the plugs for us, and they expect to move the material incredibly quick. So we're trying to get all those plugs together so that they know exactly how much material they have to move so they can get those guys in if it only takes them 3 weeks and they want to schedule 3 weeks for them to be in to do it. So.
Okay.
And then
Sounds good.
we made a decision last week because right now SWCA is still on a 14-day quarantine on both sides of travel. So if you were to fly down to Lower Bodark, you'd have to quarantine 14 days on either side. So talking to Lee and Joseph last week, we decided that we're not going to have SWCA staff go down to Bodark until after this quarantine period for SWCA. So what that means is that the guys from basically Luis and Aaron and Ryan will go down and survey, and then they'll send you guys the data to work up the as-built data from the office. And then at some point, the travel restrictions and the 14-day quarantine will be off, and then we can get back to business as usual, going down to Texas and stuff. So.
Okay, sounds good.
All right, and then I think Corner Canyon's done for right now. We may get you involved today. I'm going to be talking to Kennard, and we may get you involved in Strontius Springs hill slope modeling for looking at erosional processes from the hill slopes. So we may be doing that later today as well. So.
Okay. All right, cool. Thanks, Dave.
All right. Well, hey, are you able to leave the house yet?